Welcome to the lecture number 20 of Theory of Computation. In this lecture, we will go through the equivalence of PDA and context-free grammar. Then we will go through how to convert a grammar to a push-down automation. So you know that the context-free grammar is accepted by a automation that is called as push-down automation. And the push-down automation can accept a string by two ways. One is push-down automation by empty stack, and another one is push-down automation by final state. So these two are equivalent to each other. And you know that as a context-free grammar is equivalent to push-down automata, the context-free grammar is equivalent to both push-down automation by empty stack, and the push-down automation by empty stack is equivalent to push-down automation by final state. So you can say that the context-free grammar is equivalent to or is accepted by PDA by empty stack, and which is equivalent to PDA by final state. So if these are equivalent, now we will learn how can we will convert a context-free grammar to a PDA. Means if a grammar is given, how to find its equivalent PDA, and we will learn how to convert a PDA to an equivalent grammar. So in today's lecture, we will go through the procedure of converting a grammar to a push-down automation. So you know that a grammar can be represented by four tuples. That is nothing but V, non-empty finite set of variables, T, non-empty finite set of terminals, Q is the number of productions, and S is the start symbol. So let VTQS be a context grammar. So what do we want to do? We want to convert this context-free grammar into an equivalent push-down automation. So here we will convert the grammar to a push-down automation which will accept the string by empty stack. Okay, so the push-down automation accepts a string by two ways. One is by empty stack, another one is by final state. So here we will concentrate on how to convert a context-free grammar to a PDA that will accept by using empty stack. So you know that the PDA consists of 7 tuples. One is Q, non-empty finite set of states. Here it is input alphabet. So here input alphabet will be equivalent to the terminals of the context-free grammar. Next, another one is push down symbol tau. So here the push down symbol tau will represent the union of variables. So you know that the context-free grammar has four tuples: variables, terminals, productions, and the start symbol. So the tau is equivalent to the union of variables and terminals, and delta is the transition function, and Q is the initial state, and S is the initial top down stack symbol. Now what is the final state? Here, as we are accepting the string by empty stack, here the final state is 5. That's why in your book it has been omitted. Okay, so here while converting a context-free grammar to a push-down automata, we will follow two steps. Okay, so I will explain you these two steps by help of one example. So for each variable a, so in a context-free grammar, for example, let me go through this example. Here this is a given a context-free grammar. So here how many productions are there? S gives to 0BB is a production. B gives to 0S is a production. B gives to 1S is a production. And B gives to 0 is a production. So here what are the terminals? So here B is nothing but, so there are two variables. One is S, another one is B. What are the terminals? So the terminals are nothing but 0, right? So what we will do in step number 1, for each variable a, so the variable is in which form? A gives to beta. So a production is in the form A gives to beta. So here you see S gives to 0 B B. So here this is a production. This is in which form? This is in the form A gives to beta. So where A is equal to S and beta is equal to 0 B B. So what we will do if such a production is available, then we will do delta of Q epsilon A equal to, we will write QB. So you know that the push down automations instantaneous description is in this form. So the push down automations, the transition function is what? So here it will take the state Q, then it will take the push down symbol, and it will take the input. So here this is the input, and it will look at the push down symbol tau, and it will map to another state Q, and here it will push or pop a stack symbol. Okay, so the transition function of PDA is in this form. So how we will convert the grammar to a push down automation? It means nothing but we have to find out the transition function of the push down automation corresponding to a given grammar. So in the grammar you will have either variables or terminals. So for variables there is one rule, and for terminals there is another rule. So here let me consider a single production. So here S is a variable. Okay. So here the production is S gives to 0 BB. So what you will write? Delta of. So how we will write the transition function of the push down automation? You see here we will write delta of Q. Q means it is a state. So delta of Q, comma. What is the input? Input is epsilon. Input is epsilon. Then here what is A? A is nothing but the production A gives to beta. Okay, so A is the left hand side of the production. So here what is our production? S gives to 0 BB. So here what is A? A is S. So here what I will write? Q epsilon S is equal to, what I will write? QB, Q beta, sorry, Q beta. So here I will write Q. So here what is beta? Beta is nothing but 0 BB. So we will write 0, right? So now let me go through another production. So let us go through this production. B gives to 0s. So delta of Q epsilon. So here B gives to 0s. What is A? So this is, if I will write, A gives to beta form. So here A is B. So here I will write B. Q epsilon B is equal to, I will write Q. What is the beta? Beta is 0s. So here I will write Q. S. This is dead easy. Okay. Next, let me go through the next production. B gives to 1s. So what I will write? Delta of Q epsilon. What is A? This production. What is this production? This is nothing but B gives to 1s. Okay. So A gives to beta form if I want to put. So A equal to B and beta equal to 1s. So what I will write? Delta of Q epsilon B is equal to U1s. Right? Similarly, let me go through this production. So delta U epsilon B equal to U. Here I will write 0. Right? Now you see I have converted all the productions to its equivalent transition function of the push down automation. Now so I have completed the step number 1. Now I will go through the step number 2. So for each terminal small a. So here in this example, what are the terminals? So the terminal is 0 and 1. Okay, so 0 is a terminal and 1 is a terminal. So for the terminal, what I have to do? Delta of QAA means Q terminal equal to Q epsilon. So here what I will write? Delta of Q terminal. What is the terminal? 0. So 0 is equal to, I will write Q epsilon. You see, I have just written the same thing what I have written over here. Delta QAA equal to Q epsilon. So in that example, what is A? A is nothing but the terminal. So terminal, what are the terminals? 0 and 1 are the terminals. So here what I will write? Delta of Q 0 equal to Q epsilon. So this one I have written. Then what I have to write? For 1 again I have to write delta of Q11. Here Q11 is equal to Q epsilon. So this one I have to write. So delta of Q11 equal to Q epsilon. This one I have to write. Okay, so here you see by following those two steps, we have converted this grammar G to a PDA. So here what is the grammar? Grammar in the grammar there are these are the productions. So I have converted the grammar G into a push down automation. Into a push down automation here what I have written? I have just written the transition function. So from the transition function, you can easily identify the 7 tuples of the push down automation. Okay. So here Q, how many states are there? A single state Q is there. What is the input alphabet? 0, 1. 0, 1 are the input alphabet. What are the stack symbols? So stack symbols is nothing but the combination of variables and terminals. So the stack symbols are 0, 1, S. These are the stack symbols. What is the transition function? This is the transition function. So these all are the transition functions. Okay. Next, what is the next thing? The next thing is delta. Transition function is over. Next, the initial state. What is the initial state? U is the initial state because there is only one state. Okay. Next, what is the start symbol or what is the initial push down stack symbol? That is S. S. Next, what is the final state? So here the final state is 5 because we want to accept the string by using empty stack. That's why the final state I have put it as 5. Now you see here in this question, convert the following grammar to a PDA. So first part is over. Next what you have to do, test whether the string 0, 1, 0 to the power 4. It means what? 0, 1, 4 zeros, 0, 0, 0, 0 is acceptable by this PDA or not. Okay. So for that what I have to do, so here let me draw it. So initially in our stack, what is the initial stack symbol? The initial stack symbol is S. Okay, so we will start from this production. U delta of Q. So we will start from. What is the input alphabet? Epsilon. So or here what is the initial string? 0, 1, 4, 0, 0 to the power 4. So here I will write 0, 1. What is the start symbol? S. What I will do, I will go through Q of 0, Q comma 0 BB. So instead of S, I will insert 0 BB. So here I will pop S, here I will insert 0 B. So now my stack has 0 BB. Okay, so here what I will write Q 0, 1, 0 to the power 4. Instead of S, I have written 0. Right? So by using this, let me write the name of these heads. Rule 1, rule 2, rule 3, rule 4, rule 5, rule 6. Right? So now here you see U00. So in the input you have 0 and at the top of the stack you have 0. So what you will do? I will use rule number 5. Q00 means I will erase one symbol from the stack. So I will erase one symbol. So by using rule number 5, I will erase the 0 from the stack. So now what I have? I have processed this 0. I have popped this 0 from the stack. Now I have 1, 0 to the power 4, comma, stack. Now you see Q is the initial, Q is the state and 1 is the input and B is there at the top of the stack. So which production you will use? Here you cannot use any production, but what you can do, if I will take epsilon as input, so epsilon is there before it and after it and in between it. So Q epsilon B. So Q epsilon B means which production I can use? Q epsilon B. So what I will do? I will write Q0S. So here I will write Q 1 0 to the power 4. So in place of this B, I will write 0S. So I will pop this B and here I will write S and here I will write 0S is there, 1S is also there. So here as I want a 1, I will use Q epsilon B gives to Q1S. So I will use this production. So that is nothing but R3 I will use. Okay, so instead of this B, I will write 1S. 1S, here B. Right? So now what I have? I have Q1, Q, sorry, not Q1, Q 1 0 to the power 4, 1 0 to the power 4, and here what I have? 1 SB, 1 S. Okay, so what is the content of the stack? Let me see the content of the stack. It's 1 SB, so it's 1 S, right? So now you see Q input is 1 and at the top of the stack you have 1. So which production you will use? So Q 1 you have the input and 1 is there at the top of the stack. So you will use this production, that is nothing but rule 6, Q epsilon. So by applying rule 6, what we will do? We will erase a 1 from the top of the stack. So we have erased this 1 from the top of the stack. Now what we have? Q 0 to the power 4 S B, because we have erased this one from the top of the stack and we have consumed this one from the input string. Now we have 4 zeros. So this one is equivalent to Q 0 0 0 0 S B. Okay. So now here we want a 0. So which production we will use? So here you see, in order to get a 0, we can use this one, rule number 1. Q epsilon S. So here you see Q, before it we have epsilon and here we are having S. So Q epsilon S means Q epsilon S means what we can replace with? We can replace with Q0BB. So we can replace this S with 0BB. So I will write Q0000. So in place of this S, I will write 0BB. 0BB. So in place of this S, I have written 0BB. 0B, right? So now you see at the input I have a 0, at the top of the stack I am having a 0. So which production I will use? So you see Q00 is nothing but Q epsilon, means I will erase a symbol. So this is nothing but R5. So here I will use R5. So Q, I have consumed this 0. So how many zeros are remaining? 3 zeros. 0 0 0, and here 1 I have popped out. So what I will get? I will get B B. So now Q 0 is there at the input and B. So here I have 0 popped out. Okay. B is there at the top of the stack. You see. So which production to use? So Q0B. So Q 0B, there is no production. So what we will do? We will use a epsilon before it. So Q epsilon B. So you see Q epsilon B. So we have 0s, 1s, or we have 0. So we will use this production R4 so that we can eliminate the 0. So here by using R4, what we will have? We will have Q 0 0 0. In place of B I will use R4. R4 means in R4 what we have done? We have replaced it with a 0. You see Q epsilon B, we are replacing it with 0. So here we will replace this B with 0. Okay. So here we will have 0 B. Now you see Q input is 0, at the top of the stack you have 0. So which production you will use? So Q, you have 0 as the input, 0 at the top of the stack. So you will use the production Q epsilon, means you will erase a symbol. So here you will erase the 0. So this 0 will be popped out. So this 0 will be consumed and this 0 will be popped out. So what you will have? Q00. Now again what you can do? You can use the rule number 2, so that rule number 4, so that you will have Q00B. So you will replace the B with 0. So this is rule number 4. Now what you can do? Q0 is there as at the input and 0 is there at the top of the stack. So what you will do? You will do the erase operation. So erase operation, this is which production? This is production number 5, R5. Okay. So you will do U0 by using R5. Okay. So this 0 is omitted. Now Q0B means Q epsilon B. So which production you will use? You will use R4 and you will get U0 0 over here. This is R4. Right? By using R4 you have got this one. Now what you will do? So this B will be replaced with 0. Okay. So now Q00. So which production you will use? This production you have to use. Q00 means what you have done? Q epsilon. Q epsilon means what? You have erased one symbol. So you have consumed this 0. Now you have Q epsilon. Now this symbol will be erased. So here you will get epsilon. So this one will be erased. So now you see your stack is empty. Your stack is empty means what? This string 010 to the power 4 is acceptable by this PDA. Is that clear? Now you see the same string you can also derive by using this context free language. How you will derive? S gives to 0 B B. Now in place of this B, if you will use 1s, B gives to 1s. So what you will get? 0. In place of this B, I have used 1s, 1s B. So now in place of this S, if you will use 0 BB, so what you will get? 0 1 0 B B B. Now in place of this B, if you will use 0, so what you will get? 0 1 0. You see B gives to 0 is there. In place of this B, you can use 0. So 0 1 0 B B. Now in place of this B, okay, 0 0. Now in place of this B, you can also use 0. So what you will get? S gives to 0 1 0 0 0 B. Now in place of this B, you can use 0. So what you will get? S gives to 0 1 0 0 0 0. So you see, you have obtained the string 0 1 0 to the power 4, that is 4 zeros, from the start symbol by using the production of the grammar. So you can derive it by using the productions of the context free grammar, or here what we have done, we have converted it into a PDA, and by using the PDA we are able to say that this string is acceptable by the PDA. It means what? The CFG and the PDA, what we have written over here, both are equal. I hope all of you have understood how to convert a grammar to a PDA.